So the protocol for these classes, as you'll see, is they are recorded. There's a screen capture that goes on, so it'll pick up my voice, it'll pick up everything that's present on the screen, and it will ultimately then be uploaded onto YouTube. Also, for those of you who are here a bit earlier, you'll have seen that we kicked it onto Adobe Connect, so it's being broadcast as well. And so if you log into the Adobe Connect meetings room, I guess, which is my Ellsworth meeting room, you can actually get it from wherever you are, well, wherever you are, period. And so you can get it live or you can get it delayed, depending on your desire. So we'll talk about attendance policies and kind of the philosophy of that today, I think. But everything, as I say, is served to you on the course webpage. You all will know well how to use Angel now. I guess what you would see would be this on your Angel page. There's a syllabus. There are a couple of group assignments, one major assignment, which is a presentation at the end of the class, which we'll talk about. Some useful equations. There's a 400-page tome, which is this combined copy, which are all the notes, basically, that we'll use in the class. And so you can download that. Some of them, I mean, you may like them, you may not like them, doesn't matter. That's the way they are. There's a course book, as you know. And then there are also exams and solutions for the last 4 years' worth of classes. So Angel has all the resources on it that you might need. And so what we'll do today, I think, is we'll just go through and look at the materials that we have. I guess, where is it? So I guess it got closed. So where is it? I could download them just as easily from Angel, but I can also get them just as easily from here. So most of these materials, I think, are included in this one file, which is going off screen here. So that's this. So you'll get to see how we do it with thinking. So I just want to go today. I want to go through the syllabus that we have. So typically for each class, we'll have some goals that we want to go through. So this is the first class, week 1, first class, and this is our tasks, I guess, for what we want to get through today. The assignment is online, and so let's see. Can people see this at the back, by the way? Can you read at the back? Can you still hear me at the back? If my voice goes down, then just shout or throw something and to get my attention. So it's an 8 o'clock class. Sorry. I kind of like 8 o'clock classes. The reason it's an 8 o'clock class is because there's almost 300 students in it. And to get a big enough classroom, as in this case, we need to go into quote-unquote, non-prime time hours. So that's why we're here. I encourage you to come to class. There is no class attendance policy. There's no doubt that it's, I think, better to come to class. I would say that, of course, but I think it's an indication, I would say, of engagement, your engagement in the class or commitment to the class, that you do it in real time. You could do it real time here, or you could do it in real time online at Adobe Connect, but I think that's important to engage. There's no doubt that I try and track performance of students who do come to class versus who don't come to class. It's not always an easy thing to do. One thing I can do is that the exam scripts that don't get picked up are typically those ones that don't come to class. So if you look at the relative scores on exams between those who have engaged, come to class, and those who haven't, it's probably a 10% difference. And so that's it's a full letter grade, not a grade, but a letter grade difference in those. So I think there is some value in attending. The people involved in this are myself, and so that's me, Shang Li, who's sitting over here. There are office hours attached with these as well. Shang Li's office hours are Tuesdays and Thursdays in the afternoon. And Nick Ward is the undergraduate student who also has office hours on Mondays and Wednesdays. So those are all in the in Hostler building, in 111 Hostler. It's the study room that's got the numerical code pad on it. And so I encourage you to utilize those. I think it's something that's you have access to. So if you need it, you should use those resources that are available to you. All of the materials that we do, I can't open these hot links in this particular one, but I guess I can if I just do this, I think. All the stuff that we do is put onto YouTube if you feel interested in doing that. And so all it is a very straightforward class capture. We started doing it last year. We only started at the end of the third week, so the third class in the third week. I can't remember why 4.1's missing. Perhaps there was an exam on that day instead. And so these are just straightforward recordings of what we're doing now. So we're recording exactly the same thing. And so you can look at them on your iPhone as you're riding the bus in here to maybe get in for class or maybe not get in for class, depending what you're doing. And so you'll see what we do from that. So I'd encourage you to go and look at those to see what's there and to see whether that's something that you ultimately want to use. But we'll do that anyway. Still not sure exactly what we'll do once we get to the end of week 3 when we have those things from past years. I don't think that we'll stop using them, but it may well be that we think about flipping the classroom. Of course, if we flip the classroom and have you do the lectures at home on YouTube and then come to class to engage in some problem solving, then maybe negatively for some of you, it changes the kind of attendance policy and we would have a full attendance policy. So maybe you don't want that to happen, but that might be one of our options as we go down the road. So anyway, still undecided exactly what we'll do, but that might be one of the options. The other facility which is open to you is that these are all recorded on class capture. And so you should be able to log in. If you have a laptop open here, you should be able to do it right now if you're on the wireless network. If you log in with your user ID as a guest or you log in as a participant, you should be able to log in and participate. And I guess I don't know whether some are. There's a screen right there, right? No, I'm on my lonesome. So if you want to log in, you can do that. So, does anyone have a computer open here that they're interested? Can give it a shot? No. All right. What else? This is skim. The prerequisites for the class are there. Math 250, 251, which I guess is ODEs, PDEs, and Physics 212, which is physics. I personally don't exercise any prerequisites. I don't know whether our department does, but if you have those or don't have those, you're more than welcome to join us. Of course, you have to be conversant with the material, I think, to do well. I think if you can differentiate and integrate slightly, and you also know this, then you're probably okay, because that's the bedrock of everything we do in this class, is Newton's second law. And so I don't know whether our department will exercise the choice to remove people or bump people out of this. I guess you'd know early on in the semester if that's the case, but certainly I don't plan on doing that myself. Never have. We run this class, I think, on kind of personal responsibility. You have to sign up and take care of your own responsibilities. The evaluation is as you have there. There are 13 or so assignments. They're done online. I guess let's come back to this. I guess I didn't say anything about the book. I said I would in the email that I sent out. So I got an email last night from someone saying we didn't have class today. I thought that was kind of curious. I replied to them that we do have class. But the only email I thought I sent out was saying don't buy the book yet until we have a chance to talk about it. Has anyone got the book, by the way? How much is it? Do you know?
120 bucks.
120? No, that's fine. Yeah, fine. So that's the reason. So it's 120 bucks. I would say buy it. I don't think you absolutely need it. There are a couple of versions or a couple of volumes in the library on 2-hour reserve, so you can get it if you wish. The one thing you do need the book for are for the weekly assignments, which are the numbered questions in the back. So there are 13 or so weekly assignments. They're done online. The first one of them is live now on Angel. They are typically due every Thursday at midnight. We leave them on until 2 o'clock or something, but that's our choice. We leave them on because we don't want 55 emails from people, well, I'm doing it at 12:05 and I just missed out, and can you reset it for me? So, but it closes at midnight. Almost every Thursday, not this coming Thursday, but a week Thursday is the first one, you'll be required to do an assignment. You will see them. They're in the book. You can, I'm not sure exactly what feedback you get for these. You can certainly game the system. There's no doubt that you can game them. You get 3 attempts, is my recollection. And so you can game the system, and some do, I think. But I would encourage you not to do that. Obviously, it's against the Penn State's integrity policy. What's it tell you? It tells you which ones are wrong, which ones are right. And of course, you can share that with yourself. Yeah, you know, you can guess how to game the system. I would ask you not to do that. I would encourage you not to do that for obvious reasons. This is one of the places where you learn how to do the stuff that we talk about in class. And so, so you need to make your choices about that. Clearly, it's against Penn State's integrity policy, which is AD 4227. No, I guess this one here, right? This academic conduct. So it contravenes that, but that is where the assignments are. It's your responsibility, if you choose not to come to class, not to send me emails saying, is there an assignment due this week? Because I typically won't respond to it. I presume that you come to class or you listen to the videos, all the information there is applied there, and that's where you should get that information. And that's, again, your personal responsibility to do that. So there are 13 of those, roughly once every week, to do those. There is a group presentation, and that will be where we arrange you in teams. And there are a couple of components online that explain this in terms of what it is. It's probably easier for me to show you exactly what it is. Whoops. By looking at, for instance, a couple that I made up, if those are opening. And so 25% of the grade is 15% on assignments and then 10% on this class presentation. Class presentation, we will make groups for you. There are 300 students in this class, give or take, I think 285. We've typically done this in groups of 5. We'll assign them just the same way as when you work in a company. You'll work in teams with people you don't know, might not get on fantastically with, but hey, that's the way it is. And the assignment is to be able to make a 1-slide PowerPoint presentation that talks about some curious observation in fluid mechanics. And so a couple of very straightforward ones I think are given here. So one I think is quite straightforward is so when you look at, well, in my generation, perhaps not your generation, when I was growing up, we used to look at these Second World War movies of boats plowing through heavy seas, and you could always tell when it was a model ship or not a model ship. And the question is, how do we know that? What is it in terms of what we look at that allows us to be able to do that? So we're going to ask you to have some kind of hypothesis or some curious observation of fluid mechanics that you'd like to be able to explain straightforwardly by some kind of analysis, very straightforward analysis. Let's see if this will work or not. Yeah, so I don't know whether the audio will work on this.
What did it look at?
I never saw anything like it. An enormous wall of water coming towards us.
In the early morning hours of New Year's Eve, Gene Hackman, Ernest Borgnine,
try this.
Red Buttons, Carol Lindley, Roddy McDowell,
No.
Stella Stevens, Shelley Winters,
No,
Jack
we're not going to get
Albertson,
audio on
Pamela
our
Sue
movies
Martin,
anyway. Oh.
Arthur O'Connell,
So Poseidon
Eric
Adventure.
Shea,
Anyone
and
seen
Leslie
Poseidon
Nielsen
Adventure? Anyone know what
were
Poseidon
aboard
Adventure is?
the SS Poseidon
Yeah, okay.
when it
One
was
Timothy.
hit by a 90-foot tidal
No,
wave.
it's a ship going across the ocean, gets hit by a tsunami.
capsized.
And, well, perhaps
Poseidon
not everyone
Adventure.
knew then, perhaps you do or don't know now. If you look
The
at
most exciting
the
escape
deep sea where a
adventure of our
tsunami is, it
time.
might be a few centimeters high.
Follow me! It took the
Rather
lives
than
of the
being much
1,400
larger.
people
Once it
on
gets
board
close to land, then it can
and
be much
changed the
larger.
lives of
But
the
typically
few
they
who
might
would
be
survive.
a few tens
Climbing
centimeters
to
or a
another
meter
deck will
out
kill
to
you
sea.
all. And sitting on our
And
butts is not going to
let's
stay
see if
with
we
either.
see some ships going over. Did it get hit by a wave already? Did I miss that? Oh yeah, okay. Too busy talking. So where was it? After this? Must be. Alright, there we go. So it's too busy.
Tidal wave Oh my
Oh yeah.
and
So
capsized.
is that the real ship?
The Poseidon Adventure.
Not. You think not? I think it's
The
not
most
either, right?
exciting escape
Probably
adventure
this
of
isn't
our
either.
time.
So why
It took
is
the
that?
lives
So
of
the
the
question is why
1,400 people on
why
board
are you able to
and
figure
changed
out
the
in your own
lives of the
mind
few who would
whether it
survive.
is a model or not?
Climbing to another deck will
And
kill
so,
you all.
a couple of
And sitting on our
hypotheses.
butts is not going to stay with
So
either.
one is that the velocity of the water droplets that you see floating around is somehow scaled differently. Well, it's not scaled, it's universal scaling, right? So if I drop a pen, it falls at a certain velocity, and acceleration, rate of acceleration gains velocity, independent of whether it's in the model frame or the real frame. Of course, in the model frame, if it goes 5 centimeters, it's covered the whole height of the
Academy
ship.
Award
In
winners
the ship
bring
frame,
you
it's got to go
Irwin
probably
Allen's
50
production
meters to be able to
of
cover
The
that same
Poseidon
thing. So
Adventure.
the time it takes,
Ronald Neame
maybe a
film,
fraction of a
coming
second
from
to maybe
20th
many
Century
seconds to go
Fox.
through it on the ship side, is something that would allow your eyes to basically scale between the two things. Because you see a droplet of water going from the top of the mast to the bottom too quickly, and your eyes are attuned to figure out exactly what that is. So you can do, very simply, figure out exactly whether that's the case, as to how long it would take to actually travel, and you can look at the scaling of that to be able to show that that would be one clue, for instance, why you could scale it. So that's not so much fluid mechanics, except, of course, what we'll find out about fluid mechanics is that if I take a racquetball ball and throw it around and hit you in the chest with it, it's not very different from me putting a hose on you, and the beads of water which hit you in the chest destroy momentum and put a force on you in the same way. So F equals ma applies equally well to fluids as it does to this drop of fluid flowing down in this particular case here. So that's one case. The other thing that you could imagine could be that the water droplets are just too big. So if you see a water droplet that when you scale it relative to the model, which happens to be the size of a football or a medicine ball or one of those balls that you roll down inside a hill in, is just too big, the question is, can you get droplets that would be that large? And you know from your experience with raindrops that, well, raindrops are quite small. They're probably, what, a couple of millimeters across, as you see. You certainly get hailstones much larger than that. But water droplets that come out of the sky don't come out any larger than that. So why is that? And certainly you could do the balance to be able to figure out exactly if this is a water droplet that's cut into a sphere, and you apply surface tension around the edge, which you don't know how to do yet, but you will do actually by Friday for sure, is that you can calculate what the force would be that would be applied by that surface tension. You know, the same as a water skier scooting across the top of a lake. And you can calculate what the weight that would be applied by the weight of water itself and do a force balance. And you can use that to figure out in terms of the surface tension of the water, the density of water, gravity on this planet, what the maximum diameter of that drop should be, and it comes out to be a few millimeters. And so that just confirms what you already know. You know that raindrops are typically quite small. Maybe that's the maximum size they should be, and you can actually show that that should be the case. So that's just an example of a very straightforward analysis that you could do. And so you might want to use a movie that's already on YouTube. I think this is one of someone putting water through a sieve. I don't think it's as interesting as the ship one.
A demonstration, perhaps, that you've already seen is when a glass is completely
Stan,
filled
the
with
physics
water.
guy, I guess, right?
Then a
Talking about
cardboard is
surface tension,
placed over the glass.
paraphrasing what he's doing. Well, you put this beer mat on top of your beer, and then you turn it upside down, all of a
Then the
sudden it
hand
gets
supporting the
held on there.
cardboard is
Why does that
removed.
occur? Is it atmospheric
Atmospheric
pushing up
pressure
on it on the outside?
causes the
Is
card
it
to
surface
stay in
tension
place.
that does something with it? You could do
This
the analyses to
demonstration
be able
can
to explore
actually
exactly what those things are. So
mislead
that's what
you
we'd like you to be able to
regarding the
to do.
understanding of the next
So
demonstration.
you can look at those at your leisure.
Let's
Both of
add a
those
little food
resources
coloring
are
to this
present on
water
the,
so that it's more visible.
on the web. So you have that. So I think you can choose some interesting things to do. I'm kind of losing track exactly. I guess that's where we are. And so there's a schedule to this. You can see what the grading is. I think the key is to have an interesting observation, not something that's mundane. If you look over the page, there's a whole bunch of random thoughts that you could use, or you can come up with your own. I don't think we have a list of things that people have done in the past, but yeah, I think it's an interesting thing to do. The key is getting an interesting observation in the first place. It's also good to have an explanation of it that holds water, so to speak, no pun intended. Some of the things that students have presented, have involved, if you take them literally, they would, people doing cardiovascular stuff, we'd all be dead based on their analyses of why things work or not, but that's okay. It's part of the adventure, I think. Provide some kind of interesting analysis for it and come to some conclusion. So the deadlines are that we'll give you teams by September the 11th, which is probably a Wednesday, I think, in a couple of weeks' time. We'll ask you to meet with your group. We'll ask you to get a topic by the 9th. We would like you to report the topic because we don't want to have those topics duplicated. We don't want everyone doing why does rifling on a barrel for applied so you straight flight of a bullet, or why do you spin a football when you're throwing it? There'll be many people who want to do those. But we want to get unique topics for each of the groups. So there is, I guess, some incentive to get your topic in early because it is first come, first served. We'll confirm with you whether that topic's okay. The ones that are duplicative, we'll ask to resubmit. And then you'll upload your presentation file on the 4th, which I think is also a Thursday, for the presentations in the final week of class. So we'll probably, if we have groups of 5, and we have a 5-minute presentation. So 3 minutes for presentation, minute for questions, minute for change out is a 5-minute cycle. And so we can get 10 of those presentations in one period. We can get 30 in 3 periods. I think we'll have to have some evening sessions as well. Maybe if some of you want to record them on YouTube, then you can upload them and you can give us those links if you feel shy or you think you can do something more creative. I think that'd be fine as well. That'd be fun to do. I think it's all in the quality of the topic you choose. So there are a variety of modalities. We've never done the YouTube route before, but that might be something that you might choose to do. The grading is based on, when I grade them, I always put them in rank order. So no 2 can be the best presentation. There's a first, second, third, I guess all the way down to 60th now, will it be? It's kind of tough to put those in your mind. They go into quartiles. Man, I put a lot of time, this group put a lot of time into this. This group, we're engaged with stuff. These guys got started late. And then there's the I don't give a crap group, which there always is one as well. We've never met until we walked into the meeting. And so there's a special grade for those in terms of deficient presentations. But I think it's something that you can have some fun with, and I think it's something that you have some control over in your syllabus because you can control the scores. So certainly you should be able to score pretty close to full scores on the assignments. If you put your heart into it and work on it, there's no reason why you can't do the same on the group presentation. The rest of the class is evaluated on exams, 3 midterms and a final. Midterms are worth 15 points each. We've talked today about engagement in the class. Do you want to grab a thing? We've talked today about engagement in the class, doing the assignments properly. I'd say that I don't know what the key to success is, but it seems to me that a lot of people get repeatedly. We've had the first exam being a bit of a bloodbath. And so you should be mindful of that, because I've said it. You should engage now and start preparing for it. I think maybe part of the problem is that people think that the assignments, which are really very short, straightforward questions, moderately easy to do, I'm sure all of you will be able to do them without having this first week of class, I'm guessing, most of them anyway. The exams are a bit more involved in that. They're multi-part questions that lead from each other. So I would say that if you want to be successful in this class, I would strongly encourage you, I think it's on this first sheet, I would strongly encourage you to go to the past exams and look at them now. I don't know whether that will make you successful or not, but I think it would give you at least a context in which to process the kinds of things that we're doing. So do that today. You know that this time of semester you have kind of hiatus before assignments and deliverables kick in, so take the time to be able to go there. These exams all exist on Angel. I guess this is Angel, right? Well, I don't want to do that. These exams all exist on Angel. Somewhere, don't want to do that. In a zip file, so they're here. I won't download them because I think it's a pretty big zip file. But if you look at where they are, I don't know where they are. I think they're here. You'll see them arranged out in terms of exams 1, 2, 3, and 4. They're done by year. And there are two things. There's a solution for each of them, and then there's the actual exam as given. And so they might not exactly correspond with each other. I don't know if you can see those or not. So these are the first exams for last time. So you see the kinds of exams. So part 1, part 2, part 3, part 4. They might not be exactly the same as the worked solutions, which is the master exam here. And the reason for that is that if I think the exam's too long, once I've gone through it myself, then we cut off some of the questions, typically. And so I would encourage you to look at the exams as you're going through this, decide whether they're easy or hard, and then gauge your engagement in the class based on that. And so those are made available to you for your benefit. So please do that. I ask you to do that today, after today. The exams are worth 15% apiece. The final's worth 30. The final is comprehensive, but it's definitely weighted towards the material in the last quarter of the class, I suppose. We grade the exams without a curve. So the grades are based on, the regular scale, which you've seen in your other things. A's are above 90, B's are above 80, C's are above 70, D's are above 60. I think many of you have to get a C in this class, so gauge your effort accordingly. What else? The exams are provisionally set. I changed one of the dates based on an SPE meeting, which I knew of, and actually me being out of town as well. But the dates for the exams right now are set for, you don't have this page in your syllabus, but it's on Angel if you print it off. They're set for the 25th of September and the 23rd of October and the 13th of November. And then the final will be sometime in this week. I suppose they'll stay those. These yellow times are me out of town time, so that's why I wanted to have the one here, but it doesn't. I think there might be a large. How many people are going to SPE meeting? A large number? Well, maybe not so many. Well, maybe we might put it to the second. I'll ask that question again after we get into class. Are there any other conflicts that I should know of, big groups of people heading out of town that might be useful for me to know of? Typically we have the main exam, the conflict exam. You have to notify us informally. You have to have a reason, being other than I need to go out to the bar that night, or I need to go home and do my laundry. Typically it wouldn't be on a Friday. We'd avoid a Friday anyway. I know you've had canning trips in the past. I guess those are Fridays, and so we avoid Fridays. They would always be after the main exam. They may or may not be the same exam as the previous exam. And I don't know if I said it, none of the questions on the exams in the 4 years so far have repeated themselves. And so I think we'll probably keep up with that for this coming year as well. Typically, the questions on exams are some spark of mad inspiration that happens during class in each year. And so that's another reason to maybe think about coming to class. So this is your schedule with the different topics as we go through. What else do we talk about? Assignments due Thursdays. The group presentation, be a group of 5 of you. Midterms are on those dates. Typically, if there's a top score of 95%, we'll add 5% to everyone's grade to take it up to 100 so that you get that. My reason for not using a curve is basically the idea that you need to know this stuff. You know, many of you, you're engineers and scientists. Many of you as engineers, you have the public trust. You have to safeguard public welfare. So not knowing what you're doing with fluids can kill people, obviously in the worst situation. It may not seem that way, it may seem trivial, but if you look at things like the Macondo incident and many others you can think of, not just in fluid mechanics, but understanding that is a portion of your duty and public trust, and that's why you get licensed ultimately as a professional engineer if you're eligible for that in one of your accredited programs. And the strictures of that are that you hold some trust for the public. So that's the reason for not, that I give anyway, for not using grading on a curve. But so lots of information, but basically there's no reason why you shouldn't absolutely get 100% on this. And if you think early about what will be on the exams and look at those materials to get some kind of feel for it, try doing those examples blind maybe and using the worked solutions as backup, then I think yeah, everything will be just hunky-dory, and you might even have some fun in this class. And so hopefully that'll be the case. For exams are closed books, closed notes with a calculator, and a double-sided page of equations that you can, or whatever you want to do. Some people have the worked examples from the textbook, which they've got the solutions manual for, and they have 1,000 little postage style size pages on these, and probably relatively good eyes, better than my eyes these days, to be able to do that. You can bring whatever you want on that piece of paper. It just has to be 2 sides only and a regular letter-sized sheet of paper. My style of coming to class, by the way, is each day I bring some notes on a piece of paper and then I talk around it and scribble some things on the board. So I think you probably realize that already. What else? Yeah, and so you'll see that some of the exams are multiple choice. We don't do that anymore. Maybe for 2010 and 11 they were. There was rampant cheating, and so we killed that, and so we don't do that. For each of we work through the book, through a large part of the book. I would say the one part of the book we don't do is on compressible flow, but you can see from the different topics, we'll start off talking about properties of fluids, maybe today, tomorrow, and Wednesday and Friday. We'll talk about fluid statics and pressures exerted on structures. So that's everything that we'll do about statics. We'll talk about fluid dynamics. Many of you will have seen Bernoulli's equation before, which is it's basically the statement of F equals ma for a fluid. And then we'll look at a couple of conservation behaviors. Conservation of volume. Volume in equals volume out plus accumulation. Conservation of linear momentum, where we're able to look at not only fluids that have no viscosity, but fluids which critically do have viscosity, and be able to understand the behavior of those. And then we'll also talk about energy machines, like trying to calculate the energy that you can derive from a windmill, from a hydro plant, from burning fossil fuels, less our interest than thermo in that. We'll talk about some very straightforward ways of being able to characterize fluid mechanics systems in terms of non-dimensional variables, which are incredibly important in all schemes of science and engineering, especially in things like fluid mechanics for petroleum engineering, where you use type curves for solving well drawdown problems, and for the same applied in groundwater hydrology for that matter. And then we'll talk about the two closing parts are when we talk about viscous losses in pipes or porous media or in well bores, for instance, and also viscous losses of flows around structures. Structures might be wind turbine blades, they might be airplane wings, they could be a variety, they could be buildings that are pushed on, doesn't really matter, but you can perhaps see what the individual applications would be. So viscous flow in pipes, which is here, external flows and the forces that they apply on structures like wings and propellers and turbine blades. And then we'll talk a little bit at the end, just for closure, on the behavior of systems of open channel flows. So flows within rivers and streams and ditches and tunnels that aren't filled with water, etc. Academic conduct, you know what that deal is. There is no class attendance. I certainly encourage you to attend. I encourage you to engage. I'm not making up the details about the 10-point differential in the exams between people who do physically engage and those who I suggest have not engaged. Yeah, so you're in control of your own destiny in some respects. Those are the schedules of how we'll do it. As I say, the last week we'll have. We're not finished yet, so don't get too hopeful that you can pack up yet. In the last week we'll have the presentations in class, but also perhaps in the evening, or perhaps we'll just get rid of class and just do them straight in the evenings for a 2-hour stretch on 3 occasions or so. So I've done all the talking. Any questions that we haven't covered? Covered a fair amount of ground. Interaction is always good. No? Okay. All right. So I don't. What else? All right. So there's also on Angel there is a list of useful equations. You decide yourself how useful it is. What we'll do is with each of the topics that we do, we start off with the appropriate topics. So the first week will take us down to this on upwards. And so by the time we get through the first week, hopefully we know something about all of these individual components. Believe me, you'll understand it. So it won't just be something that doesn't make, hopefully it won't be something that doesn't make any sense. So let's just talk very briefly about why this might be a course that's interesting and useful to you. So certainly fluid mechanics is everywhere around us. You can look at it in terms of things that affect us by just us physically living on this planet. And those would include, I guess you missed out on that this year, but for instance, 2 years ago, well, certainly if you're living in the northeastern U.S., you felt the East Coast earthquake, right? In September, the magnitude 5.9 earthquake at Mineral Springs. Wasn't tsunamigenic in our particular case, but certainly in your lifetime, 2.25 years ago, there's the Tohoku earthquake offshore Japan that the tsunami killed 18,000 people. We do a lot of good things with earthquake engineering now. Almost no one died as a direct result of the earthquake, but the unexpected and short lead time in terms of the warning for the tsunami was sufficiently short that most of the fatalities in that were from the tsunami. And certainly the Adaman earthquake, the Boxing Day earthquake, the December 2004 earthquake in Indonesia that killed 250,000 people from a tsunami was also a fluid mechanics problem. All the geophysical circulations on the planet, including Hurricane Sandy, of course, are fluid flows. The way that we get earthquakes by subduction and the movement of plates of maybe 50 kilometer thick on a mantle of many hundreds of kilometers of molten rock that overturns by convection, by buoyancy, something that we'll talk about in this class. And the slow viscous flow of this is also a fluid mechanics problem. Flow of ice in ice sheets is a power law. It's not Newtonian viscosity, as we'll see, but it's driven by a power law. If you double the force that you apply, it doesn't move twice as fast. It moves less than twice as fast. And things like upwelling of magmatic fluids in volcanoes. Mount St. Helens was certainly before your time, right? If you're 20 now, then I guess you're probably born in about 1993-ish, of that order. And so this was, I think, May the 18th, 1980. So 13 years or so before you were born. It certainly affects us in engineered systems. If you flew into town, if you live further away than parts of Pennsylvania or Jersey, then if you flew into town, then certainly you used some of the principles of fluid mechanics, hopefully, to get here. In terms of your different majors, we've talked about the public trust and your obligation to that public trust as safeguards of the safety, people who safeguard that public trust in terms of the Macondo well incident of 3 years ago? 2 years ago? 3 years, right? 2010, I think, of BP, which is still going on in the Gulf, and the court cases still continue. I was talking to someone on the way home who called me up about coming to our meeting, who's a witness for, I guess, the U.S. government in determining what the spill was. So the question now is, how much came out? Because now the damages are related to the number of barrels that came out at some large amount of dollars per barrel. If you live in the U.S., the network of gas pipelines that cover the country is flow in pipes, which is viscous flow. If you live in the Northeast, if you live in America and pay only $3 for 1,000 cubic feet for natural gas when it used to be $8 1,000 cubic feet a couple of years ago, it's because of the fracking revolution, which isn't in some people's minds is an expletive. Not in everybody's, only made possible now because we can drill wells that now go horizontal and that could be massively hydraulically fracked. Driving fluids into a formation and splitting it open is intrinsically a fluid mass balance problem, coupled with solid mechanics, but one that involves fluid mechanics nonetheless. Getting fluids along the pipeline is a fluid mechanics problem. Water or gas and other fugitive fluids escaping into overlying aquifers is a fluids problem. Geothermal energy, pumping cold water down, bringing hot water out, is a fluid mechanics and heat transfer problem. Groundwater contamination is a fluid porous media flow problem. Windmills, of course, turning as a result, kind of the reverse of an airplane with a turboprop is a fluid mechanics problem. Anaconda, generating electricity from the motion of waves, from the articulation of joints. The movement of that assemblage is driven by the fluid underneath. And of course, around the time of this class, maybe 3 years ago, was the time of the Air France 330 going down in the Atlantic Ocean. Everyone lost. All because a pitot tube, which you see as you board the small planes here, as you walk up the ramp, you see this little thing sticking out of the side of the plane that measures the velocity the plane is moving at. So it measures a stagnant fluid pressure here and a fluid pressure flowing past it, uses the difference between those fluid pressures to tell you what the velocity of the plane is. If you don't know the velocity of the plane, absolutely, then you don't know whether to speed up or slow down to stop from stalling. And that's exactly what happened to this plane, is it stalled and then it basically flew into the Atlantic Ocean and was only found a couple of years later, was physically not known where it was. It just disappeared. And so the final thing is we also use fluid mechanics in recreation. It's the way that sailboats work. They're not typically just a flat sail that gets pushed, but they're basically wings as well that have aerodynamic lift attached to them. The big innovation, probably in your time for the America's Cup, was that the boats used to get put into the water and they used to have shrouds around their keels. And they used to have shrouds around their keels because the keels were top secret. They had these fins on them to give better stability and to give less drag as you go through the water and perhaps more control. But certainly keels and rudders are all hydrodynamic components. This is one of the swimsuits that they used. Maybe in the London Olympics they didn't use them, but maybe, what was the one before London? Was it Australia? No, it wasn't Australia. What was it? Where? Beijing, yes, of course. Beijing was 2008, yeah, Beijing. So I think they're wearing these in the time of, I want to say not Tommy Phelps, Michael Phelps. They're wearing these shark suits that generate this kind of slip between these scales here that make you actually go faster. And they stopped those now. They didn't have them at the past Olympics. I think the other innovation in Beijing was that the pool that they had in the magnificent water cube, which is a truly magnificent building to see on the outside anyway, was actually deeper. And so you don't have the interaction effect from the swimmer and 6 feet under the swimmer, the reflections of energy and disturbance of the flow field as a result of that, but you can swim faster in a deeper pool. And that's why there's so many world records, I think, set there. Why does a baseball curve? Certainly 10 of your groups will choose to do that as your question. Why does a golf ball have dimples so it can go further? Certainly 5 of you will choose that as your presentation to do. Skiboarding is a balance between the drag of the person going through the air, the drag of melting snow underneath, and the weight of the person going against gravity. Skiing West Virginia is exactly the same. You're going down the front of a wave, you've got gravity pushing you down, you've got the wave going up against you, and the two balance together in some way to be able to allow you to stick on a wave and be able to surf it. And of course, why do people spin footballs? To give them more directional stability. So those are things that are all around us. So my hope is that you can embrace this class, you can participate in it, you should make sure you get a syllabus if you don't want to have it, and we will continue on this next time. I will post this on YouTube, but before you go, do remember thank you.